Dear all, greetings wherever you are. I just want us to look at this problem together. It's sent to me this evening by one of you, a favorite viewer, and I wish that we should share it together. Do I have solved it for him? The problem reads thus: let R be a relation defined on Z. We know Z is a set of integers such that A relates B if and only if A is congruent to B modulus M. Show that R is an equivalence relation. As we all know, a relation defined on a set is an equivalence relation if on that set that relation is reflexive, is symmetric, and is transitive. So we will show here that A relating B if and only if A is congruent to B mod M is both reflexive, symmetric, and transitive. We begin with a reflexive property. Reflexive property. We know that for all A in Z, comma, A relates A, then R is reflexive. That means A relating A, if and only if what? A is congruent to A mod M. And A congruent to A mod M means M divides A minus A. M divides 0. Thus, A relates A. We go to symmetric property. Symmetric property. A relation R is symmetric on a set if A relates B means that B relates A. So let A relate B. A relating B means A is congruent to B mod M. This means M divides A minus B. If M divides A minus B, it means that A minus B is equal to K times M for some K in the set of integer. Now, we can multiply both sides by -1 to have negative times A minus B is equal to negative Km. And this gives us B minus A is equal to M times negative K. Now remember that if K is an integer, negative K is also an integer. And this means that M divides B minus A. M dividing B minus A means that B is congruent to A modulus M. And B congruent to A modulus M means that B relates A. So this relation is symmetric. Since A relates B means B relates A. We go to transitive property. Transitive property. A relation R on a set is transitive if we will take A, B, C. Let us have A, B, C coming from Z. This relation is transitive if A relates B and B relates C, mean A relates C. If A relates B and B relates C, then A relates C. Means that the relation is transitive. Or even if we end up having C relating A, since it is already symmetric, it will still mean transitive property holds. Now, let us have A relating B. A relating B means that A is congruent to B modulus M, and this means M divides A minus B. This also means A minus B is equal to some K1 times M, where K1 is an integer. Now, we call this one, that means A minus B equal to K1M. We call this one equation 1. B relating C by the same definition means that B is congruent to C modulus M. It means B minus C is equal to K2M, where K2 is coming from Z. That means B minus C is equal to K2M. Equation 2. If we add equation 1 and 2, we'll finally have A minus C is equal to K1M plus K2M. A minus C is equal to M times K1 plus K2. K1 is an integer, K2 is an integer. It means that K1 plus K2 is an integer since the set of integer is closed under addition. That means A minus C is equal to MP, where P is equal to K1 plus K2. And this means M divides A minus C. M dividing A minus C means that what? A is congruent to C modulus M. And A congruent to C modulus M means that what? A is related to C. We have seen that we have proven the reflexive property, we have proven the symmetric property, we have proven the transitive property, and then we conclude, since R is reflexive, symmetric, and transitive on Z, we conclude that what? R is an equivalence relation. So guys, that is it. Do well to subscribe, do well to share, so that together we learn. I'm waiting for your comments in the comment section. It's from your comments that we correct our errors and look forward to serve you better. Have a nice time.